Okay, so I'm sure most of you know about Barcelona Supercomputing Center, but I think I have to do that because maybe some people is not aware of what is our role in Spain and Europe. So it's a national supercomputing facility in Spain. We have these two main objectives, which is to provide services to the Spanish and the European users, but also we are performing research on different domains that I will spend some one slide on this matter, which are doing research on computer science, life sciences, and engineering services. We are a public consortium conformed by the Spanish government and the Catalan government, so we have this cooperation for long and it's performing well, and they are sharing the cost that we are having. The mission of the four departments is presented here. So you have a strong cooperation with the Earth Science Department, and you know that they are devoting to climate change and to equality, but you have for sure people in the audience that have more expertise than me and getting you explanations on what we are really doing here. So that's the reason we are completely involved in destination Earth in different matters, not only in the utilization of the system, but also in the deployment of the applications and making sure that the applications are enabled through the pre-exascales and future exascale systems. But at the same time, we're having life sciences. They are also working on digital twin, but in this case of the human body at all the levels, from the proteomic level to the organs level. The case department is working on the development of applications for engineering and for society, on using very large systems to fix problems on the society. And computer science is a large department which is working on the development of the new technologies for the future exascale and post-exascale system, from the hardware level to the software level at any level. So these objectives and this mission is achieved with a number of people. So at this point of time, Barcelona is about 800 people. You can see the distribution on the different departments. So the computer science is already 270 people. That's the reason we are involved in so many projects at the European Union. So you can see that we are able to have aggregation of 53 different nationalities. Here's an example of the projects we are running and we are currently involved at the European and the Spanish level, to give you an idea of the capacity of research and development that we are hosting in Barcelona. But of course, the objective of the talk, and after following Sancho and the presentation from Jenny on Leonardo and Lumi, is going on MareNostrum 5. I've been presenting to AC Waste this slide for a number of years now, but this slide is still valid, okay? So our objective is to provide a system that is very large in its general purpose partition to be enabled for most of the application, that we are having an accelerated partitions for those codes that are enabled. So this is part is this here in the middle. And then we have the data processing and the new technologies that we want to try. This was published very long ago, and this ended up in a contract signed in 2022, differently than Lumi and Leonardo. The contract was signed in October 20. This is 22. And at the end, the system is ending up with a 205 petaflops sustained under Limpak aggregated system. Okay, so this is on similar to the other consortium. So we are a consortium by the European Commission, Spain, Portugal, Turkey, that are delivering this capacity to the European level. After the award of the preparation, we start with the preparation of the site, and the site I have summarized here. I don't want to spend much time on, but it was a large facility of 900 square meters. I mean, it was because with the current system configuration we will be using 85% of the floor space for the MareNostrum 5. Okay, on energy, I have to highlight, of course, and it was a requirement from Euro HPC. We are using green energy at the top capacity and the contractual level. We are prepared for up to 20 megawatts. We're expecting to use 10, okay? But of course, we're extendable to 40, okay? At this point of time, we have emergency line and 1 + 1 megawatts for UPS, okay? So we are considering we are a research institution, and then that means that we are not supporting all the data center under UPS or diesels or emergency lines. For cooling, we are having the heat reuse on the building and the area of the Barcelona with the university. We have designed the data center for a PUE of 1.08, okay? And that's the volumes of water that we're moving to guarantee the chilling and the cooling of the system. So we have 3 circuits, and the 3 circuits are to guarantee that we can achieve the PUE of 1.08, okay? So the most of the data center will be cooled with DLC, derivative cooling, from 30 to 40. I would prefer to go higher, 35, even 50. But these days, the technology is not permitting these opportunities, okay? And the bottom, you can see that we are still going to 8 and 17. So we need still to cool the air and to remove the heating of some racks with rear door heat exchanger. The residual heating is something that is really worrying me, because it's hurting the total cost of ownership of the system. But this is the way. What I'm really interested in these days when we will start in production is in the preparation of the water quality and the treatment of the water, because I heard very nice experiences on the US and different locations on how to guarantee the water quality of the system. So I'm looking forward this analysis. So MareNostrum 5 at the end, so you can see in this background the chapel, no, sorry, is the data center that is prepared for this machine. Okay, it will have a networking based on NDR200. It's a FAT3. It's not a full FAT, but it's having some contention in some of the connections. The central part, from my point of view, if the storage is the file system, it's about 250 petabytes on hard disk, 2.8 on NVMe, and 400 on tape. So we decided to install also a tape library for guaranteeing the long-term sustainability of data. I know that most scientists prefer to have everything on spinning disk, but I still insist. We don't have the capacity to read out that on full speed on the system. So we have to leverage the cost and the interest of storing this amount of data. We're expecting to have this installed and accepted by the end of January 23. Okay. The next partitions to be installed will be installed in April 23 and June 23. So we're expecting that the system will be available for final test, on early test of the users by July. So it's coming with a general purpose partition with Intel Sapphire, which is a significant size and partition. So this is a 35 sustain under Limpac. So it will be the significantly larger partition of the Euro HPC systems installed. And the objective is that we can accommodate most of the workload. On the right-hand side, you have the accelerated partition, which is coming with the new Sapphire Rapids, but also with the new NVIDIA Hopper. Okay, so it will be composed of four different sockets of Hopper in every node of the Bull-Sequana system. And continuing, let me get apart so you can read this slide. And continuing with the objectives of BSC, we want to also make sure that we're able to test new technologies. Okay, and these new technologies are including these two parts. So we're expecting by the end of June 23 to have available a general purpose processor based on NVIDIA Grace up to 2 petaflop sustain. And then later at the end of 23, partition with Emerald Rapids and Rialto Bridge, which is the evolution of Ponte Vecchio. The objective, as usual, to give the opportunity to the users, to the communities, to get early access to the technologies, and to enable the porting of the applications and codes to make sure that when the system is ready, we are ready to go. So here you have an idea of the configuration. I'm sorry, I cannot share more details because it's under NDA. I'm surprised still, but it's still under the NDA because there are a lot of new technology. So you can see it's greater than, because otherwise you will be able to extrapolate the capacity of the Sapphire Rapids and the Hopper systems. The information is not available officially. Okay, so I have to disclose only these figures. So for the general purpose partition, you see is DLC and rear door. Why? Because DLC is just capable to remove 95, 96, 97% of the heating of the system. But every one of the racks is using about 80 kilowatts. So if you are losing 3 kilowatts, you still need to cool that. And that's the reason we have asked to extend this with rear door heat exchanger. So this partition will come with different nodes and with different configurations. So we will be including a quite small partition, but using HBM. So we want to make sure that we're able to use HBM Sapphire Rapids to test some of the applications and to make sure that we are able to boost the performance of some applications that require HBM memory, of course, with a smaller memory footprint. And then we will be having a very large 2 gigabytes per core and a smaller partition with 8 gigabytes per core. Okay. You can see that this is NDR200 shared by 2 nodes, so it's 100 gigabits per second connection per node available for the connectivity. The accelerated partition delivered by Atos. So, excuse me, I didn't mention. So Atos was winning the tender process by EuroHPC, and it's aggregating a number of technologies from different vendors. So the partition from accelerated is provided by Atos. It will accompany it with nodes, which including 2 Sapphire Rapids and 4 NVIDIA Hopper, and a very significant configuration for networking. So every node will be including 4 NDR200 to guarantee the data transfer between the different nodes. You can see at the bottom the configuration of the Grace Hopper partition and the Rialto Bridge partition. Here are the figures. I don't want to spend details, but that's to explain you the complexity of installing this system, so which is including different technologies in the same data center to guarantee what is the required cooling mechanisms with the different workload that we may be running all day long. Okay. So for me, what's important to remark is this last row, which is whether it's room neutral or whether we have to make sure that we are removing the heating of the room, because you see the room is quite large anyhow. Of course, we are having additional racks for the InfiniBand network, for storage, for archive, and that's it. Okay, so you see that the storage is growing significantly. So we're expecting that nowadays a rack with storage is coming to 20 kilowatts, meaning that if we are having about 25, it will be using a lot of energy only for the storage capacity. For software stack, we're ready to accommodate any of the software stack from x86 to the NVIDIA partition. So everything managed with a single file system under Spectrum Scale and with a simple queue system Slurm, so you will be able to shift workload on the different systems. So we will be installing EA, which has been deployed and managed at BSC, and it's now a mechanism that allows to guarantee that with the less energy you are performing your jobs at the same performance. Okay, so that will be saving a lot of money. So this is being used already for LRZ from Munich for long now. So to conclude, because I want to make sure that I'm ending on time. So what is next for us? Okay, so next for us is we need to build, install, and accept. Okay, we are working on schedule. First racks will come in early December. And we're expecting to have the largest partitions accepted by the end of June. We have to prepare applications in software stack. It will be easy because the configuration is easy to take it. We will be training users. We want to make sure that we are opening calls, that the system is fully loaded from the very beginning. You may notice that we're having an international support team. It's not only from Barcelona, but it will be including people from Turkey and Portugal, because they are co-owners of the system. So we want them involved in the system. And on the left-hand side, we have next things. So we will be installing a couple of quantum systems attached to MareNostrum 6, one from Spain and one from EuroHPC. And we are working already in MareNostrum 6. MareNostrum 6, you may heard that we are interested in Barcelona. In RISC-V, we are developing a mechanism to guarantee that we can start procuring a system of MareNostrum 6 and building to make sure that in 5-6 year times, we are having a system that is really accommodated to the applications and the user needs. Okay. And with this, I finished on time, on schedule. Thank you very much.